Now let's come to discuss a class diagram, or simply we can say the object oriented analysis or object oriented analysis model. What is class diagram? Class diagram describe the structure of the system. Remember that class diagram lies in the category of static diagram. There are two categories of diagrams or models, UML models, static and dynamic. So it lies in the static category. Class diagram describe the structure of the system, software system, by presenting the system's classes, the respective objectives, attributes of each classes, and operations or methods, and the relationship among the objects. So class diagram is nothing but class diagram shows the different classes with their respective attributes and operations, and how different classes are related. So this means we will see the type of relation also. So we have 5 6 normal used relation types. Class diagram depicts the static overview of the system, as I stated. Class diagram shows the object-oriented analysis of the system. Remember that class diagram is very important, very important. Why? Because with class diagram, we analyze the requirements. We analyze the detailed functionalities, the concrete details, the attribute, operations, dependencies. So these are the detailed functionalities. So with class diagram, we analyze the system, the internal structure of the system. So one advantage is analysis. Using class diagram or object-oriented analysis, we can structure the high-level software architecture. What is high-level software architecture? The high-level software architecture shows the different modules, components, and the link of different components, such that how one component communicate or one module communicate with other. In simple words, I would like to say that the software component is a class. Normally we have one class belong to a component. So this means class diagram helps to structure the high level architecture, and also the low level design is based on the object oriented analysis. So this class diagram or object oriented analysis model is then given to the designers and then developers. So there are a lot of advantages of learning the class diagram. Class diagram is the base for showing the components of the system, and class diagram helps in reverse engineering process also. We do reverse engineering to go back to the design and software requirement specification phase. Means from develop software we go back. And what can be the reason? Obviously we do some enhancement. If we want to do some enhancement, improvement in the design, in the modules architecture. So how it is possible? So it can be possible if we do a reverse engineering or analyze the documents. But if the documents are missing, so we can draw the class diagram from the developed software, and then we can start the reverse engineering. Importance of object-oriented analysis. As I stated, requirement analysis, design both high level and low level, and then become the base for programmers. Pieces or components of object model. First is a class type, which shows particular class name with specific defined goal. Mean the class name, either it is a student, professor, subject, department, so any entity can be the class. So definitely each entity must have some specific name. Relation of one class object with other class object. Remember that class is a generic concept. For each class we have infinite number of objects. For example, student. John is a student. King is a student. Stephen is a student. If we talk about the professor, so different professors are possible. So this means if we talk about the relation of one class with other class, alternately this is the relation of one object of belong to class with other object belong to some other class. Attributes. Class is defined over its unique attributes. Like if we talk about the student, so student is defined over the attributes such as what is the student ID, what is the name, the address. The attributes are the attributes of the student class. And the operations, which are actually the detailed functions of the class. If we talk about the relations, so different relations possible are simple association, directed association, aggregation, composition, dependency, and generalization. So now talk about each relation type. Association. The name association means some link, the link or linkage. So this means association is used to describe one object can be associated with other. Remember, associated, not dependent. In association, one class does not depend on other, but are linked to other class, can use the service. For example, class 1, class 2 are in association. This means both classes can use the operations, the services of other class. This does not mean both depends on each other, but only associated in bidirectional way. This means both classes can use the other class. Examples of simple association: student and subject. So student and subject, remember that in association the two classes are independent classes but use each other. Like if we talk about student, student is an independent class, does not depend on subject, and subject does not depend on student. But for some purpose, for achieving some goal, student and subject class can be associated. Similarly, company and product, patient and doctor in association, car and owner, employee and office. Office is used by employee and employee use office, or we can say office is allotted to the employee, or employee each employee has some dedicated office. Now talk about the unidirectional association or directed association. The difference is that one specific class can use other class, or we can say one particular class, specific class is in association with other. An association relationship is bilateral by default, but the directed association shows the flow of control or dependency in one direction. Here one class does not depend on another, but can be associated with it. This means class 1 is in direct association with class 2, but class 2 is not in association with the class 1. This means class 1 use or get help in services from class 2. Example of directed associations. Accounts and bank. So account is registered in the bank. Bank is not registered in the accounts. So if we talk about our bank account, we always say my account is in particular bank. We cannot say this bank belong to account. Sensor, hardware sensor can be heat sensor, smoke sensor, any sensor, light sensor, sound sensor, belong to bus. Server, in association with the client. Now talk about another relation type, which is the aggregation. In aggregation, target class is a part of source. This means, in simple words, both classes are combined together. But remember that combined together for some specific goal, but loosely coupled. This means they are not tightly bounded, or in other words, we can say that we can split this relation such that both classes can then exist independently. But both combine, both aggregate, and then do some specific role. So in aggregation, two classes loosely combine for some goal or task. This means two classes in aggregation can exist independently. Now see examples. Battery and fan. How battery in isolation exist, and we can say battery can work in some other with some other class also, but fan without battery is useless. Here we are talking about the DC fan which work on the battery. So if battery and fan combine, then it will achieve the goal, which is the purpose is the cooling purpose. So if we isolate, we can isolate fan from battery, but when they aggregate, they do some specific task. Similarly, department and professor. So professor belong to department, department has professor, and both combinedly do the services. Chapter and book. Book with no chapter or chapter without book is useless. Photo in a frame. Room, house. So if we see if we see the house, we can find many rooms. So if there is no house, room has no benefits. So room and house combine. Similarly, books inside the library. So all these are in example of aggregation, but remember these are loosely coupled. Now talk about the tight couple, strong couple, which is called composition. This means both class is composed. Two classes in strong couple such that both classes cannot exist independently. Two classes strongly combine for a single cause or purpose. Target class is a part of the source. Remember one thing, that both in composition and aggregation, there should be one target and one source. So target class is a part of the source. This means here there should be one target and one source. So here fan is a source, book is a source, frame is a source, house is a source, and target is a room. Example of composition classes: heart and human. Heart without human cannot exist, and human without heart cannot exist. Means strong couple. Menu and order. You will not see menu without order, or order without menu. Principal in school. So you will not see, never see school without principal, or principal without school. Student without college, and college without school. So student and college are in strong couple. Room and hostel. So this is not possible that there is a hostel and without room. And engine and car. So you will not never find a car without engine, and engine without car is nothing. So there is a minute difference between aggregation and composition. The difference is that both depend strongly, such that the both classes does not exist independently. Now, simple dependency. Here one class depend on other, but other class does not depend on the previous. It is a relationship in which one class depends on other. Execution of one class depends on other. This means for execution of one class, we need other class. Here, there is a difference between these two concepts: composition, aggregation, and dependency. Here in composition, both depend. In composition and aggregation, classes combine for some purpose. Here one class depend on other. Order and product. So order depends on product. Factory depend on machine. But factory, remember that, like we talk about the human and heart. So that is something else. Both combine and give a live human. But factory can exist without machine but depend on machine. And machine can exist without factory, like in shops there are machines. But factory class depend on machine but can exist. In composition, one class does not exist. Salary depend on attendance, car depend on product, and car depend on oil. Remember that in last example, car and engine are in composition, but here car and oil are not in composition. Why? Because car can be designed without oil. We can push the car to, to start its motion. Or it can be possible that there are lens on the top of the car, and battery is charged from sunlight, and then car can go. But still car depends on oil. There is another concept which is called generalization. One or more child inherit property from some base class or parent class. Here we mix one class as generic or parent and the rest as a child classes. So remember that one parent can have many child, but child has only one parent. There is normally. So generalization limits repetition of attributes and operation, because child inherit properties from parent, and this is the advantage of generalization. Let's see bank account. So this is the base class or parent class, and two derived classes or child classes are current account and saving account. So these two attributes share some of the unique properties from the bank, like bank address, bank ID, contact address, etc. Manager. Fruit. Mango and apple both are fruits. Shape. Rectangle and triangle classes both belong to shape. Bike, truck, and car all belong to vehicle. We cannot say, we cannot put mango and bike together. Similarly, student and professor belong to person class. Both will share some of unique characteristic like person name is both for user and professor, person address, contact number, blood group, etc. Publication. If we publish some article or book or magazine or paper, so all are publications. Class diagram for point of sale. Point of sale is a sale system which comprise of sale module and purchase module. Remember one thing, that before class diagram we draw the use case diagram. Why? Because classes are derived from the use cases. One use case can comprise of one class or can comprise of many classes. So it is better to draw the use case first. And in our previous lectures, we have also shown the point of sale using the use case diagram and the sequence diagram. So these classes are derived. Purchase class, sale class. Purchase class purpose is to manage the purchasing of products. So further, purchase class is composed of the purchase main and purchase detail. This is the purchase module, and these are in strong couple. Why? Purchase cannot exist without detail and detail cannot exist without purchase. Remember that purchase can exist but is useless. Why? Because if we create object of the purchase main, so what will be the purpose? Obviously we will purchase some products and purchase products are here. So let's see the attributes: invoice number, date, supplier ID, bill amount and amount paid. Total bill amount and how much paid to the supplier. And purchase detail include the one of the attribute from this product ID. So different products are mentioned here. Sale price, discount given to top, purchase price, quantity, net price. And these are the operations: receipt generation, deletion, edit record. Similarly, new record, delete record, save record and edit are also the operations. Both are in composition. Both in composition means that both comprise a purchase complete module. Because handling, why we need here two classes, this is another question. So due to the reason is that laterally when class diagram is mapped to the ERD, so we put primary key on invoice number, so repetition of invoice number is not possible, and in one invoice we can have several products, so thus we need to distinguish and make a separate class. So we can see purchase has a relation with the supplier and purchase detail has a relationship with the product, but the two relations are different slightly. Here purchase detail depend on product. This means this cannot be successfully or cannot be success or cannot be implemented or cannot be fulfilled without products. But purchase class can be implemented, accomplished, executed without supplier. If we are purchasing something but we are not mentioning supplier, so we can do. But we can say this class still has a relationship with supplier, and this is the direct association. This means purchase uses supplier class. Supplier class, this means association. There is some association. A purchase class has association with supplier, but supplier has not direct association with the purchase because supplier is not using purchase. We talk about the account, supplier accounts. So supplier account depend on the supplier. If there is no supplier, we cannot open the account. But supplier account is in direct association with purchase. If we split this relation like this, if we split this relation or this, so still purchase and accounts can exist. Here purchase can exist without supplier and supplier accounts can exist without purchase, but still in association. What does association means? If we are purchasing something and bill is finalized, for example, finalized bill is $10 and we give $3. So this means this $3 and the remaining $7 will be entered in the supplier accounts. But we can also manually or direct enter debit and credit in accounts without mentioning the purchase. But if the entry is from the purchase, this means supplier accounts is in direct association with or using purchase. Similarly is the case with the sale. Sale is in direct association with the customer. Accounts is dependent on the customer, and a customer account is in association with the sale. And we have like purchase detail, we have sale detail, both are in strong composition, and sale detail depend on product. This was the class diagram for point of sale. Now service and product provider web application. This is already covered, also covered using the sequence diagram and use case diagram in our previous lectures. So this is the generalization concept is used here, user. So here service and product provider and buyer. I forgot our buyer. What does it means? That somebody will provide products for sale, or can provide, anyone can provide the services. Services can be the human services like a tutor, or can be the technical services like someone is mechanic, someone is a labor, someone is a designer, etc., etc. And buyer, so buyer can be the product buyer, can be the services buyer. So all are the humans, users. So we make one class and generalization concept is used, and either it is the employee buyer, employee service provider, service buyer, labor service provider, and product buyer and product seller, all are the persons. But there is no inheritance here. Why? Because payment and user, here users and payment are linked with a direct association. This means user will enter the payment detail, or while entering the detail of payments, we can enter the user detail. Similarly, seller and product both are in association. Product come from the seller, or seller write some products, but product belong to the product category. Like if we talk about the clothes, so all the clothes belong to the cloth category, all the stationery belong to stationer, all the fruits, either it is a mango, either it is a apple, belong to the fruit category. So generalization concept is also used here. Similarly, labor services, labor category, and there is a simple association, bidirectional association between the labor services and labor service provider and labor services buyer. So this was all about the class diagram for the services and product provider and buyer web application. Now there is another concept used which is called associative class. This means a class which produces some association between other two classes. So associative class produce association of two other classes. Sometimes the relation of two classes is meaningless with introducing some associative class. For example, relation of student with the course. Here this relation can be either attendance, exam, enrollment. So student and course has many possible relationship. So then we introduce the associative class. Like we see the example, person and company. So person can be the head, person can be the assign any role in a company. So role is a associative class. Similarly, student and class is associated with exam class. And similarly, student and course can be associated with the professor. So this professor associative class means this associative professor class is producing association of teaching course, particular course student. Like we have different object types also possible. Entity objects, which represent the information tracked by the system. Boundary objects represent the interaction between user and system, and control objects represent the control task performed by the system. Like example of entity objects include year, month, day. Control objects examples are change date function. Change objects and interface objects example are button and LCD. With button we give the input, we change the date through button, and then we can display the output with LCD. So this was all about the class diagram. Hope you understood today's lecture. Thank you so much for watching my video. Thank you so much.